So, what does Spotify, Google Maps, and Chess Engine have in common? Well, they know the future. And how they know the future is hidden in this one thing, that is the rules. Let's understand this. So, right in front of you, you have this whiteboard, and I draw a ball on this. And seeing this ball, now this ball, if I were to tell where would it go, it can go left, it can go right, it can go up, it can go down, and n number of directions. So the degrees of freedom are endless. What I do is that I draw this boundary that is just enough the size, that is the diameter of the ball. Now we know that it can either go left or it can either go right. Knowing this, it is not difficult to say that you know some sort of future for this ball. It can either be to the left of it or to the right of it. Thus, knowing the rules help us understand the possibilities of futures. And once you know the possibilities of future, you can predict what is the more likely probability. But that is not what we are here for. We are here for something more interesting. Right in front of you, you have these three regions. Let's call it future A, future B, future C. Each of these regions are attractors. What are attractors? Basically, understand this as having bowls and marbles. So when you have a bowl and you put a marble, it can either oscillate on the top of that bowl, but at some point of time, you know that due to gravity, it will be attracted towards the center of the bowl, down. So if I have three bowls, when I throw a marble, it has three possibilities to where it can lead to. So here's what we are going to do, right? We'll start by placing the marble near future B. It is not colored yet, it is just a grey marble. But what we're going to do is that we'll see the trajectory. Okay, it led to future B, that was obvious. It's near the future B, of course it will lead there. What we can do is that we can color it red. Why? Because we know that it will lead to red color. Similarly, what I can do is that I'll start by, let's say, putting it near future A or future C, and correspondingly, we place the color. So I just keep on doing this, and you can see that the whole black space starts to get filled with these sort of colors that basically tell you where this is going to lead to. Now, here is the most interesting part. Beautiful, right? So what it is doing is that it is computing the trajectories for each of those pixels on this screen, and what we have right now is in some way a map. Each color is basically where that point led to. So this part here led to this part here led to this, and this part here led to this. Well, that was not difficult. Once you know the rules, it's quite easy to understand the future. Till now, we were the gamers. You told us the rules and we had to follow the rules and play the game. But what if you could change the rules? Well, if you can change the rules, you change the future. And if you change the future, that is how our map also changes. And there is something really interesting about that is upcoming. For this one, you can even follow along. So what you're going to do is that you will click on your browser and open this website, gblabs.pages.dev, and thereon you can click on launch simulation. Once the website opens, you'll see such interface in front of you. Now I would avoid going into the mathematics of it for this current video. I'll go into it in the future video. For now, you can understand that these sliders that I've given here are the controllers of the future. If I can control this alpha, beta, gamma and delta, you can see the map changes. Earlier, you had those three attractors. The same three attractors are explained here through the red, blue and green color, while the yellow here is something that is called unsettled after element, like it's the chaotic part, and the escapes are again something that I wouldn't go into in this video. Let's focus on these three colors as well as the chaotic part. Now if I vary alpha, which is non-linearity, you can see something really cool, right? So you can see these varying patterns. You can change beta, you can change the gamma, and you see changing the rules change the complete map of these futures. I can even click, so I'll have it reset. If I go here, you can see that the initial condition, it represents the coordinates and the fate that will ultimately lead to, right? So the red one will lead to ultimately the root 1 basin, so it shows you that. At the bottom, we have some interesting maths that are again part of the future videos. We can go into bifurcation diagrams, the Lyapunov exponent, the sample orbit. Well, the sample orbit is quite easy. You can understand if I put it here, it shows you that if I started here, why is it leading to the red part? So just the complex map of it. Why complex map? Because the numbers we are plotting are not just x and y, we are plotting it in the imaginary plane, the x plus iy. Having said that, I'll leave you to just I'll ask you to basically go through this. You can try experimenting. There are some really cool patterns hidden in this. So for example, if you just put omega as 0 and let's say gamma as 0, you get this. That is cool, right? And then you have this delta varying. Okay, and just experiment with it, and you try to understand that what you are actually engaging with. It's really cool.